So today we'll be discussing about the inheritance and the concept of inheritance. Everyone must be knowing. In C++ we have read inheritance is the property of an object to inherit the properties of another object. And there are different kinds of inheritance: single, multiple, hierarchical, multi-level, and hybrid inheritance. I think this I have already discussed. Have I discussed or not? Hello? Is it being discussed in
No,
the
sir.
class? Not this.
No, sir.
Okay.
No, sir.
Okay.
She just give idea about the types.
Okay. So it is single inheritance. If you have a class is inherited from a one base class, then it is, we say it is a single inheritance. So we have a class over here. This class is inherited from this class. So if a class has only one base class, then we say it's a single inheritance. The multiple inheritance says that if you have multiple number of base classes, that means a class is inherited from more than one base classes. A class is inherited from more than one base classes, then we say it is a multiple inheritance. So we can say this. So you can see this is one base class. This is another base class. Sorry for my mouse movement is good. And this is the derived class, correct? So the class is being derived from multiple base classes. The hierarchical inheritance says that there is a class from which the class B may be inherited, and from class B there might be another class C inherited. So in return, C will get the properties of A. This is also called transitive nature of inheritance. This is also called the transitive nature of inheritance. And this is the multi-level inheritance. Actually, this is multi-level. This is multiple inheritance. This is single inheritance, and hierarchical is there is a class B, and from which multiple classes may be derived. Multiple classes may be derived. Then we say it is a hierarchical inheritance. Correct? This is being derived from, and here you may write that D1, D2, D3, these are being derived like this. And hybrid inheritance says, the hybrid inheritance when there are more than one kind of inheritance exist in a system. For example, I give something like this. If I give it right some, so you see there is a hierarchical inheritance, there is a multi-level inheritance, there is single inheritance is also there. You may have a connection like this also. So you have different kinds of inheritance, more than one kind of inheritance exists, and we say it is a hybrid inheritance. And this kind of inheritance was also there in your the language that you have read C or Java. Now question is that how to implement this in Python. Suppose I have a class car. I have a class car, and the racing car is a car that I want to design, which will be derived from this car. Now you might be thinking that if the class car is there, what is this object? So any class has a base class is there, default base class is there, that is called the object. So every class inherits from a built-in basic class called the object. Every class inherits from a built-in basic class called object. Is it understood? So here the car, either if you do not write also, it will take. So class car colon, that means class car is automatically being inherited from a basic class called object. Now I have init function to initialize these variables. So init function inside the car, obviously it is taking self argument. Along with that, the color and seats it takes. So can you say that what is this? These two are, what are these two? Hello? Data members. And these are being initialized with these values, correct? Do you need a constructor always for a class? Is it necessary always?
No, sir. It's optional.
Not, it is just optional. If you want
Sir,
to,
sir,
yes.
kindly repeat again, sir.
init function works like a constructor, and it may not be always compulsory for a class, because if you not define any init function, automatic, I have already told, if you do not declare a init function, then automatically Python invokes the init of its own for to initialize the object. So you may not have a init function, but I can have data members. I can use data members, but I may not use a init function. Any doubt? I want self.color sitting capacity, but I will not use init. Will it work or not? Yes or no? I don't need to.
No, sir.
No. Hello?
No, sir. No doubt, sir.
No, let me show you how it will work. Let me write a small program and show you. Suppose class A. I am not defining a init function, correct? I am defining only, suppose, input function. I am having only input function, correct? And here I write x equals to self.x. Self.x equals to input something like enter your name. Enter a number. And I write def so, correct? And I write print self.x, and I create object of class A, and I can call now a1 dot input, and I can call a1 dot so. Am I using any init over here? I'm not using init, but still I have a data member over here, x. Are you getting me? Hello?
Yes, sir.
So if you have init function, that can be used for initialization. Okay, so you can run it. Suppose I run it with some. Oh, I forget to give the self over here. Okay. So this means that I may not have a init function in my class, because that is, even if you don't define it, invokes a init of its own. But if you have a init of your own, that means you can use it for initializing the variables. So I have just passed over here CLR, the color and seats, which are, these are two parameters I am passing, and which will be assigned to two different data member of the class. So by writing this, my class car is complete. Correct? I have some methods as well, accelerate and some other methods are there. I want to design a racing car. So I want to design a racing car, and the racing car has all the property of a car. The racing car has all the property of a car. Correct? So instead of redefining those, I am just inheriting those from the car. Now, do remember, this is important. If your base class is taking some parameters in its constructor, if the init of the base class takes some parameters, then in your derived class you should have at least that number of parameters over here. So if it is taking color and seats, then you must pass color and seats at least over here in this. So what I am doing over here, so I will pass those to the base class, and some parameters may be for its own. It has own variable, and this data member, these values are for its own data member. However, the base class takes two parameters, so we must have to pass them. I will give another example showing the same. Just see over here. It is responsible for defining the additional members of the subclass. We have additional members over here. So subclass may have additional members. It is responsible for defining the additional members of the subclass. It is responsible for invoking the init method of the superclass. So that means when I am creating an object, suppose I am creating an object R1 of racing car. If I am creating an object of this racing car, then what will happen? This will not only invoke the init function of its own, it will first invoke the init function of its base. So you have to pass how much? At least two parameters for its base and some parameters for its of its own. So it is responsible for invoking the init method of the superclass. How will you pass the parameters? Car is the superclass or not? So car is the superclass. You will pass the red and to this superclass. That means this line, this entire line, superclass dot underscore init underscore self, these two parameters must be included over here. Should be included over here. That means through the constructor of the derived class, we must invoke the constructor of the base class. In C++, what happens? Does it happen or not in C++? Is it happens or not in C++?
Yes, sir.
Same thing. But there it happens automatically. Here you just have to write base class dot this. The parameter list of init of subclass, look over here. The parameter list of init of the subclass includes parameters of the subclass as well as the superclass. So here I am not only passing these two parameters, I may pass some parameters of its own. So this is its own parameter, and these two parameters are for the base class. Correct? So the public variables, the public instance variable and methods of superclass accessible to the subclass. Which variables? Only the public instances variables or methods. private instance variables and methods will not be accessed. You do not have a protected section over here, either private or public. So public instance variables and methods are available to what? To the to the derived class. So the variables of superclass, the methods of the superclass are accessible to the subclass. Private instance variables of superclass are not available to the subclass. They cannot be accessed. Correct? And you know that how to declare private, you just put 2 underscore symbol. Okay. So 2 built-in functions that are available. One is called the each instance and is called the each subclass. Each instance says that whether the first argument is an instance of the second type or not. That means here the my car is an object, the car is a class. Whether my car is an object of the car class or not. Each subclass says whether racing car is a subclass of car or not. It returns true or false. It's a Boolean value it returns. I hope it is understood. Is it understood or not? Hello? Each instance and each subclass is understood or not?
Yes, sir. Yes, sir.
Understood, sir.
Okay. Now coming to the multiple inheritance. So as you already know the concepts of multiple inheritance, I am directly saying that how will you implement multiple inheritance? The process is same. I am while defining the INIT class of the derive or subclass, I have to pass the self parameter obviously. Then all parameters of its base classes. Suppose a class is derived from class car and class something different. So for all the base classes, if there is a parameter is constructor, then all those parameters has to be passed through this derived class. Then how will you pass? So suppose there is a special engine is a base class, you will pass self and P. Suppose car is a base class, you will pass color and seat, and the rest 2 are for the of its own. So you need to pass the parameters to all the parent classes, all the base classes. So we have 2 parent class over here, so special engine and car. Suppose we have taken over here. So therefore, we have to pass parameters to both of its parent. So this is the first set of parameter we pass to the what? To the car class. This parameter P is being passed to the special engine. You may write in any order. Parameters may be written in any order, but you have to write it over which parameter for which one. And these 2 parameters is for its own data member, own variable. These 2 are for its own variable. Correct? And similarly, this is for multi-level. Multi-level is same, multiple number of single inheritance you can think of. And in hierarchical or hybrid inheritance, the same procedure is being followed. No complex rules like in other languages are there. There is no complex rules. Very simple. The way it is being defined, if you have if your parent class has parameters, constructor are taking parameters, and through the derived class you have to pass it. But suppose the same name is there in base class and derived class. How name resolution will be there? Which one will be accessed? I have a variable X in the base class. I have a variable X in the derived class. It says that first it will check for its instance of its own. Then it checks for the class variable. If it is not, then it checks for the superclass. Is it understood? First, it will check for the instance variable. That means is data member or not. Then it checks for whether it is a class variable or not, means static data member like kind of thing or not. If it is not, it checks whether it is superclass data or not. Is it understood? The name resolution is first it will check whether it is a data member of its current object or not. If it is not the data member of correct object, it will check whether it is a class member or not. If it is not a class member, then it checks that whether it is a what super class member or not. This is the way the name resolution is being done. So for example, look over here. We have written we cannot override a private method of a class. We'll see over here. Look, suppose class A, in which I have defined method 1. Class A, we have defined method 1. There is class C, which is inherited from class A. Class C is inherited from class A, and there also we have a method 1. Is it understood? If I create an object of class C, which method 1 will be called? Try to understand. Class A has a method 1. Class C also has a method 1, but class C is derived from class A. If I create a object of class C, which method will be invoked? C1 is equal to C. If I create C1 dot method 1, which one will be called?
Not audible.
Sir, voice is breaking.
Sir, voice is not audible, sir.
Okay, I'm just repeating over here. This is class A and this is class C. C is inherited from class A. C is inherited from class A. I am creating C1 equals to C. I'm creating an object like this. C1 equals to C. And if I write C1 dot method 1, if I write the C1 dot method 1, which one will be called? Whether this base will be called or derive will be called. We can say
Sir, derived one class.
Sir, C, the D class D will be the method 1 in the class D will be run first.
class C, not D. Class C actually. Class A and C I am talking about.
Class C, yes, sir, class.
So
Oh,
class
okay, sir. Then C, sir. Yes, sir. C.
So class C will be called, right? Why it is called? Because
Yes,
I
sir.
have told you first it will search for its own instance. So in own instance it is there, method 1 is there, it will be called. But if I want to call the base, then what I'll write like this. Super. I'll write super C dot self dot method 1. Correct? So if I want to invoke the method 1 of the base class, then I'll write super C comma self. Here you have to write self. The only place where you have to write self while calling. Because before this, whenever you call a function method, you do not require to pass the self as argument. But here you have to pass the self as an argument. Correct? So by writing this way, super C comma self, correct, dot method 1. So it will go for the super class of C, that is A, and invoke the, so it invokes the method 1 of class A. If I have class D, there is another class defined, class D. The class D is derived from class C. So class D is derived from class C. Can you say which kind of inheritance it is? Which kind of inheritance it is? Which type of inheritance?
So multi-level.
It's a white class.
This is multi-level A to C, C to D. This is A to C, C to D. So it is multi-level inheritance, right? So in the multi-level inheritance, okay, so it's a multi-level inheritance. Now the class D is derived from class C. So here also you have a method 1. So class A has a method 1, C is derived from A, C has a method 1, class D is derived from C, and this also has a method 1. So if I want to print the method 1 of, if I write super of D dot self method 1, what it will call? So super of D is which one? Super of D is C. So this will call the method 1 of the class C. So this is the way in which the name resolution takes place. So you can call a function of the base class by using the super method. Is it understood? Is it understood or not?
Yes, sir.
There are some special built-in methods and attributes. So this part I am just quickly going through because it says that class contain many methods and attributes that are included by Python even if you don't define them explicitly. Some are already present, right? Some methods, some attributes are already present even if you don't define it explicitly. So some are already present in the class. So you just create a blank class, you do not write anything, but some attributes and methods are inbuilt. Most of these methods define automatic functionality triggered by special operators or use of that class. The built-in attributes define information that must be stored for all classes. So some information which are kept for a class, which are automatically being created whenever a class is being defined. So all built-in members have double underscores around the name. So all built-in, what you will find, suppose doc is a built-in, init is a built-in, all built-in has two double underscore and followed by also two double underscore symbols. And for example, the method REPR exists for all classes and you can always redefine it. The definition of this method specifies how to turn an instance of the class to a string. I want to convert an instance of a class into string. So what I'll do, if somebody writes printf, what it should do, it should call this f dot this. So if I write printf in this way, if I write printf, f is the object. So it should give an error. Rather giving an error, what I told earlier, that str will be called. Similarly, over here, the RPR may be called to produce a string for object. So if you type F at the prompt, if you just type F at the prompt and hit enter, you will get, you are actually, that means when you type F enter, it is nothing but you are calling this function. You are calling this function. Similarly, for every inbuilt function, some work is already being defined. Look into this example. I have a class student. And here I have defined the REPR, represent this method I have redefined over here. REPR is a inbuilt or not, two or double underscore followed by two or double underscore. It is a inbuilt. And here I have return this. So if I'm just creating an object of this student class. So the moment I write printf, I will write like this. The moment I write printf, actually this is syntax error. Printf is a print variable name, but here you are writing print object name. So if you are writing print object name, automatically it will call this, and whatever it is written, that will be returned over here. Or if you write even f enter, this will return. This is something like a variable. If you write, if a is equal to 15 out and you type a enter, it returns the value 15. Here also, if you write f enter, it will return this. Correct. So this is a inbuilt special method. There are many inbuilt special methods are there. INIT, CMP, length, copy. You can redefine these functions as well. That means these functions are there, but you can redefine. Are you redefining the INIT or not? INIT is there. Even if you don't give it is being called, you can redefine it. Correct. So these are some methods: INIT, CMP, length, copy, which can be used. Other built-in methods allow you to give a class the ability to use the bracket, this notation, this square bracket notations like an array or this as a function call. That can also be used. But at least you remember that some of the special methods are there which has one special meaning and which are always created when an object is created. These are the attributes. What I talked, these are the some of the methods. INIT is a method, CMP is a method, length, copy, these are methods. But there are some variables. Doc, class, module, dictionary, these are some attributes. Those are automatically being created whenever a class is created. So if you just create a class and write if you print this document string, you will find sorry, dir of that, you will find here it is written. The dir of x returns a list of all methods and attributes defined for an object s. If x is an object and I type dir of x, what it returns? It returns the list of all methods and attributes. Suppose, for example, look over here. F is an object of the student class, and if I print f doc, whatever the document string we have for that class will get printed. How to define the document string? Anyone who can say how to define the document string? Earlier I have told how to define the document string.
In between triple quote.
Yes. So here I think I have given, no, I have not written. If written in the triple quotes, if it is written in the I have not written so. No. Somewhere, if it should be written like this. Here only if I write something in triple quote over here, those will be get printed in the print as a document string. And I print, if I go for f dot class, it returns the class student class and the memory location. Correct? So I can invoke, I can use all these attributes, and you can use all these attributes for checking that how it behaves. Some more examples. See over here. I said for every object, even if you, sorry, for every class is being inherited from a base class called object. So if I create an object of the object class, so what is inside that object? You can find over here. These are default. These are default. If you will create another object by creating a class of your own, you will find some more attributes are being added. You will find some more attributes will be added over here. Right? So it should come like this. So the output will somehow come like this. So these are the data members and functions that are being present. Correct? So this is all about the object oriented. it is not that this is the end of object-oriented programming. There are some things are there, but in your course this was there, and I have some problems over here. I will discuss those, and rest of the things you will read of your own. The examples I have given. Just look over here. Python example to show multiple inheritance. I have the class base. This is the base class. Base 2 is derived from base 1. Derived class is derived from base 1 and base 2. Base 1 has a init function. Base 2 has also a init function, but they are not taking parameters. So I just write, I just have to invoke them both, but we may not pass the parameters. And through the derived class object, I'm creating an object of the derived class, right? And through which we can print strings where we can access the string 1, string 2, all these what the variables that can be accessed. Correct? You can have in this example, look over here. This is the class base. The class child is derived from class base. Oh, this has to be over here. And grandchild is derived from a child. So what kind of inheritance now it is? What kind of inheritance now it is? Base, child is from base, grandchild is from child.
The same
No, it is no multi-level.
Yes,
but
this multi-level.
This is previous one was multiple, this is multi-level. This is multi-level inheritance.
Yes, sir.
Okay. So I create a base class, but here it is taking a parameter. So once it is taking a parameter, here it is taking a parameter. So in the child class is derived from this. So you have to call the base class init method over here. The grandchild is defined from child. So it will pass, it must invoke the constructor of the child. So constructor of the child taking 2 parameters, out of which one has to given to its base. So this also has to pass 2 parameters over here. And we pass some parameters and print those. So what I am printing, look over here, I am printing, I could print the name, age and address, where name belongs to this base, age belongs to child, and the address belongs to the grandchild. I don't have to redefine them. There is a Python program to demonstrate the private members of the parent class. I say, look over here. The init method is a self.c. It's okay, but I have self.d. Look, self.d is a private. Correct? Self.d is a private member, and I said the private members cannot be inherited. C is a data member which can be inherited, but D is not inherited, right? And this D is inherited from C. It has a data member E. Correct? So, and as I need to call what? I need to call the base class constructor. So I call it over here. I may call it before this also. You may write it before this also. Correct? So I create an object of T. What will happen? As D is a private instance over here, produces an error as D is a private instance variable over here. Right? So while calling this object 1.d, this gives you an error. This is correct, object is created, but the moment you write object.d, because D is private, so you cannot access it. Is it understood?
Sir, kindly explain again, sir. Sir, actually, I short.
See, here it says D is a private member or not, because I am using a double underscore. D is a private member or not? Hello?
Yes, sir. Yes, sir.
As D is a private member, it cannot be inherited to the, this cannot be inherited over here. This cannot be inherited to the derived class. But,
Yes, sir.
but the C is inherited. But C is inherited. So if I print object 1.c, the object 1.c, object 1.e, it will print. But if I write object 1.d, then this should give you error. This must give you error. I think it's understood.
Yes, sir.
Similarly, I have class calculation, calculation 2, calculation. I have a class derive, which is derived from both the classes. This is derived from calculation 1 and calculation 2. That means this is which it is a multiple inheritance. Class derive is derived from two classes. Yes, multiple inheritance. As it is derived from multiple base classes, and therefore we have to pass the parameter. Base class 1 is taking 2 parameters, base class 2 is passing 2 parameters. No, sorry, these are not constructed. These are only the functions. So we may not have a constructor over here. So now I create an object of the derived class. I create an object of the derived class. Look over here. And through the derived class, I can call the summation, I can call the multiplication, I can also call the divide of its own. One more example. This is class bank. Get rate of interest, let it be 10. Class SBI, which is related, which is what is the object of bank class. Anyone have doubt? No. So this is SBI class is generated from bank, and class ICICI is also derived from the bank class. So SBI and ICICI is derived from bank class. It's a what kind of inheritance? Anyone who can say it's a what kind of inheritance?
Hierarchical.
Hierarchical inheritance, because multiple derive from a common base class. Multiple derived class from a common base class. So I create object of 3 and I can call it. This is individually we called. So now can you say that if I called b3.get ROI, which one will be called?
So the last one.
It will call the call of its own.
Yes.
Because B3 is an object of ICICI, so it will call itself. So the last example is class animal, where I have speak. Class dog is derived from animal. Here it can bark, and class dog child is derived from dog, right? So I can create an object of this class, and I can call all of them, right? I hope this is understood. So the module 3 is not over, rather the object oriented programming is over. The exception handling we will cover after the file handling